One. Hope you're all feeling good. It is day 9 of studying Martin every day. And today I'm about to do 2 sessions. So yeah. Yesterday I didn't study that much. Not even that much. I studied only 1 hour and I wasn't even studying. I was kinda like, just like I was kind of fatigued. Okay. I was fatigued and I couldn't even focus that much. And what I did was just to watch some lectures about math on YouTube. That's all I could do. Maybe I could do more than that, but like that's what I believed and that's what I did. So now I'm about to start my first session, and yeah, I'm about to do 2 sessions. Okay, I wanted to wake up early, but I woke up late, so I cannot do 3 sessions. So I got other stuff to do. So yeah, set up this one, this fake coded product, I guess. I don't know. I think I can even change it. I don't even need to use this one. There is a one that I have. I even, what was the name? Pomodoro timer. Just click it. Boom, focus. I used to use this one, to be honest. But the one with the cat looks beautiful, basically. I'm not logged in. Wow. Should I? Nope. Yes, they save stuffs. I like this. This is what I needed. So I'm about to start my first session. Oh yeah. So I'm gonna go back to these lectures. I'm gonna read them and I'm gonna solve some problems too. Okay. I think solving the problem or like multiplying rational fractions, rational fractions look simple, I believe, because like at the end of the day you're just gonna use the factoring methods that I have learned before. But what makes sense is just like I think my teacher is mentioning, or maybe my instructor is mentioning, or maybe in this book they mentioned a lot of information, I think. So I have to read and go through all of this, okay, in a careful. So yeah, I won't be focusing solving the problem because like it is so simple. All you need to do is to flip, basically to flip the sign. It was like multiplication and you're just gonna flip it into I mean it was division, okay, and you're gonna flip it into multiplication, and then you're gonna flip the second, or maybe the second the second rational fraction. That's the one that you're gonna flip. So the way you're gonna flip is to use the reciprocal. So the denominator will be on top and the numerator will be on the bottom, or in the denominator. That's how it is, and you're just gonna multiply. So before you multiply, you only need to like factor stuff and then cancel out. That's what you need. So maybe I can, but that's how it is. So yeah, I'm about to read factoring and cancellation. I'm gonna read it all the way from top. In this defining rational functions, in this lesson we will look at how to simplify and defined rational functions by using factoring and cancellation. Okay, factoring and cancellation. If we can find equivalent values to factor out of both the numerator and the denominator of a fraction, they can be both pulled out into a separate fraction and simplified or cancelled to 1. Here is a simple example with constant. So if we can find equivalent values to factor out both the numerator and the denominator of a fraction, they can be both pulled out into a separate fraction, just like this. So yeah, okay, equivalent is just like same values. That means find equivalent values factor out of both the numerator. Okay, numerator and denominator of a fraction, they can be both pulled out into a separate fraction and simplified or cancelled to 1. Here is a simple example with constant. So it was 4 plus 2 divided by 8, and then the way we are going to factor out will be, it's just like they have a equivalent values to factor out. So it is 2. So 4, if we pull out, like if we put 2 outside, or like if we factor out 2, we will have only 2. And also if we factor out 2, we will have 1, and we factor out 2, we will have also 4. So we're gonna pull out into separate fraction. So this is what I mean. Okay, that's what I mean. So we're gonna pull out this 2, I mean, which is like this 2. Is that how it is? Yes. Okay, we're gonna blow this 2 and this 2 into a separate fraction, and then we're gonna cancel, right? So after that we have 1. It's just like 2 divided by 2 is equal to 1, and 2 plus 1 in the numerator and positive 4 the denominator. So yeah, everything is just looks good, I believe. So we were able to factor a 2 out of every. We were able to factor a 2 out of every term in both the numerator and the denominator, then pull them out into a separate fraction, simplify that fraction to 1, and we are left with a similar fraction. Here is an example with variables. Okay, still 2. So you're gonna you're gonna factor a 2 out of every term, right? So you're gonna factor a 2 out of every term. So you're gonna factor 2 out of every term. Okay, yes, it is what it is. Yeah, so basically this is how it became. So we're gonna pull out this 2x and 2x into a separate fraction, and this is what it is. Okay, and at the end of the day it will be just 1, and yeah, we cannot add, so because like these are not like terms, and this is how we will end up. So yeah, beautiful, to be honest. Okay, so let's go into dividing rational fractions. Okay, when we divide one rational fraction by another, the first fraction is the dividend. Wait up, yeah, okay, yeah, got it. Okay, when we divide one rational fraction by another, the first fraction is the dividend, the second fraction is the divisor, and the result of doing the division gives us the quotient. Okay, so dividend divided by divisor is what quotient. That's what it is basically. So the way that they will give us will be some thing like this, you will have one, basically something like this. So this is one fraction, okay? This is the numerator and the denominator. This is one fraction. Maybe something like this, 2x, and then another one, like another like division line, maybe divided by line. So then you will have something like this also, for x divided by 2x, something like this. So what that mean is, when we divide one rational fraction by another, the first fraction is the dividend. So the first fraction will be the one on the top, okay, basically. And then okay, the first fraction is the dividend, the second fraction is the divisor. So the second one will also be the divisor, which is just like basically the second fraction in this case, okay? And the result of doing the division gives us the quotient. So dividend and divisor, quotient. Or like, do that mean if you do this, if they do 2x divided by something like this, 4x, it can be this one too. So yeah, just like when we divide one fraction by another, we turn the division problem into multiplication problem. To do this, we flip the divisor upside down. We flip the divisor upside down and change the division into multiplication. So the problem instead becomes dividend times 1 divided by the divisor is equal to the quotient. So yeah, so this is the reciprocal. Wait up. I think I'm using this terminology wrong. I don't know. 2x divided by 4x. If I flip this fraction upside down, can I say I did? Can I say I did? I don't know how to spell it. Reciprocal? Is that how it is? Reciprocal. Yes, maybe. Yes, flipping a fraction upside down, exactly what we call finding it is reciprocal. So yeah, here is what it is. I was right. So yeah, once we have changed the division into multiplication, we will multiply the numerator together to get the new numerator, and multiply the denominator together to get the new denominator. Okay, once we have changed the division into multiplication, we will multiply the numerators together to get the new numerator, and multiply the denominators together to get the new denominator. It makes sense. Okay, then if there are any common factors between the numerator and the denominator, we will cancel those common factors in order to simplify the quotient. Okay, let's look at an example so that we can see the transition from division to multiplication in action. Find the quotient of the rational functions. So it's this one. Okay, x plus 2, x minus 1, x plus 4, and x minus 1. Okay, will these guys cancel out? Yes, for sure, they will. Okay, find the quotient of the rational functions. X plus 2, x minus 1, x plus 4, and x minus 1. Okay, to find the quotient, we will flip the divisor, the second fraction, upside down, and simultaneously change the division to multiplication. So we can rewrite the problem as x plus 2 divided by x minus 1 times x minus 1 divided by x plus 4. Now that we are doing multiplication instead of division, we can combine the fractions by multiplying across the numerator and across the denominator. Okay. What do they mean by like multiplying across the numerator and across the denominator? I didn't get it. Is this just like wait up? I kinda didn't get this point. What do they mean by this? What do they actually mean by this? Okay. Didn't get like multiplying across the numerators. So you just like nah, this is not how it's going to be. You first need to cancel out this, right? I don't know why you first need to. If they mean like the normal foil like method, or maybe like multiplying the first polynomial into the second polynomial, if they mean that, yeah, I got it. But like first we have to see what can cancel out, I think. So let me check. What do they mean by this? Okay, exactly. When multiplying fraction, the process is much simpler than division. You just multiply straight across. Okay, so that means yes, this is what I mean. Okay, I got it. A couple of tips to keep in mind if possible. Simplify before multiplying. Cancel common factors between numerator and denominator. This keeps numbers smaller and easier. Always check if the final fraction can be reduced to. So if you can simplify them further. That's what they mean. So at this point, I think they should mention like canceling out these factors instead of like. Yeah, they first need to cancel these common factors. But yeah, it is what it is. Okay, so we have got a common factor of x minus. So okay, they mentioned here. We have got a common factor of x minus 1 in the numerator and denominator that can be cancelled. And denominator that can be cancelled, leaving us with just x plus 2 and x plus divided by x minus x plus 4. Okay, restrictions. Restriction is on the domain. So I think this is where she's going to mention the values that we gonna exclude of the values of x. So that means we can say x cannot be is equal to blah 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 blah. So that's how it is, because like it is making the denominator is equal to 0, and we don't need the denominator or maybe the domain to be undefined. All right, so let's just read. We have just learned how to define rational fractions, but we left out one. Okay, but we left out one really important aspect of the division problems. of these division problems. We have just learned how to define rational functions, but we left out one really important aspect of these division problems. Whenever we define rational functions, we have to consider the values for which the quotient will be undefined. Yes, we have to consider the values for which the quotient will be undefined. So it is like, yes, that's what it is. It's just like what it is. Yeah, it is the exactly same thing, because like 0 in the denominator can make the quotient is just undefined. It's just like that's what it is. Okay, gonna highlight this part. Okay, there are 3 sets of values that will make a quotient undefined. Any values where the dividend denominator is 0. Okay, so okay, got it. Any values where the divisor's denominator is 0. So like both fractions, like both both fractions, their denominator cannot be equal to 0. That's what they meant. Fractional, what do they call it? Wait up. Okay, rational functions. So both of the rational functions denominator cannot be equal to 0. So all the time we will have 2 rational functions, right? So one is the divisor and one is the dividend. That's what is going to be, right? So any values where the divisor's numerator is 0. What up? Okay, any values where the divisor's numerator is 0. What about any values where the dividend's numerator is 0? They didn't mention that. It's just like they only mentioned it today, where the dividend's denominator is 0, where the divisor's denominator is 0, and where the divisor's numerator is 0. Okay. Remember, any fraction will be undefined whenever its denominator is 0. So this first 2 value, so these first 2 value sets make sense. Of course, the dividend will be undefined when the denominator is 0, and the divisor will be undefined when its denominator is 0. We are certain okay. Remember right here. Remember, any fraction will be undefined whenever its denominator is 0. So these first 2 value sets make sense. Of course, the first dividend will be undefined when its denominator is 0. Okay, and the divisor will be undefined when its denominator is 0. We are certainly not going to be able to find the quotient if either the dividend or the divisor is undefined, so we need to make sure to state that the quotient won't be defined for any values where either denominator is 0. So it makes sense, okay? So yeah, this is what they are talking about, basically. Dividend's denominator and also divisor's denominator. Okay, I got these 2 parts. Okay, I got these 2. Okay, but like, what about this one? Divisor's numerator. Like, what the? Okay. Okay, she's saying okay that the third value set is slightly trickier. If the numerator of a fraction is 0, then the value of the whole fraction will be 0, since 0 divided by anything is 0. When the numerator of the divisor is 0, that makes the entire divisor equal to 0. But if the divisor is 0, then when we try to find the quotient, we will be taking dividend divided by 0, which like I don't know, which we cannot do. Okay, wait up. Is this something like this? Yeah, okay, wait up. The third value set is slightly trickier. If the numerator of a fraction is 0, then the value of the whole fraction will be 0. So 0 divided by anything is 0. 0 divided by anything is 0. So like you cannot divide 0 like so to anything. It's just like in a logical way. If you don't have like 0 money, you don't have 0 money, and they are saying divide it into 2 people, then you're gonna say, hell nah, dude, I don't have nothing, bro, I'm broke, bro, what should I divide, man? I go 0 in my bank account. It's just like that. Okay, so the third value set is slightly trickier. If the numerator of a fraction is 0, then the value of the whole fraction will be 0. Since 0 divided by anything is 0. So when the numerator of the divisor is 0, that makes the entire divisor equal to 0. But if the divisor is 0, then we try to find quotient. We will be taking this, okay, which we cannot do. That's why a 0 value of the divisor numerator will also make the quotient undefined. So in actuality, when we define rational functions, we need to start by considering these restrictions first and then proceed with the rest of the division problem. Let's revisit the example we were working with, and this time consider this restriction is on the domain. So before we go into that, I kinda wanna put this in Copilot. I kinda wanna do it the whole thing. I cannot do it, right? So I can kinda do this, I guess. So yeah. Okay, the passage from Algebra 2 notes dealing with a specific case. Okay, blah blah blah. Here's the context. Numerator is equal to 0. Okay, if the top of a fraction is 0, the whole fraction equals 0 as long as the denominator is not 0. Denominator, okay, it is 0 but like not undefined, and the reason that we don't, okay, it makes sense now. Any values where the divisor is numerator is 0 because like 0 divided by something is equal to 0, and if we divide like 0, if we divide the dividend by 0, which is like the divisor, basically the divisor became to 0, right? So we cannot divide 0 by the dividend. That's how it is. I think I got it. So if the bottom of a fraction is 0, the fraction is undefined. Division by 0 is not allowed in mathematics because like it will be undefined. Okay. So basically, let's do this too. Let's do this. Okay, find the quotient of the rational functions. X plus 2, x minus 1, and x plus 4 divided by x minus 1. So this time around, we will look at the restrictions considering all 3 value sets all three value sets that may cause us trouble. Okay, so first of all, the difference denominator will be 0 at x minus 1 is equal to 0. So okay, add 1 on both sides, it will be x plus 1. X is equal to 1, I mean. The divisor's denominator will be 0 at, it's just the same. Okay, the divisor's numerator will be 0 at, okay, this one, x minus 4. If we pull these results together, we can say that the restriction on the domain R x cannot be equal to, is that how they say it, or like cannot be is equal to, or cannot be equal to. Okay, I'm gonna go with the second one. Cannot be equal to minus 4 and 1. Once we have established this set of values, once we have established this set of values, we can actually do the division problem following the same steps as the last example. X plus 2 divided by x minus 1 multiplied x plus 4 divided by x minus 1, x plus 2 divided by x minus 1 times x minus 1 and x plus 4. Okay, so yeah, the rest is just like the same. The answer to the problem is the combination. Is that how to pronounce the word? I don't know. It's the combination of the quotient and the restrictions. Okay, so this is what it is. However, there is just one more thing we always have to check: the quotient itself. Given that the denominator is x plus 4, make it obvious that x cannot be equal to minus 4, since x is equal to minus 4. Since x equal to minus 4 would make the denominator of the quotient equal to 0. So there is no need to list that value as a restriction on the quotient's value, because we can see it just by looking at the quotient that x cannot be equal to 1. Restriction cannot be identified from the quotient. It was lost when, okay, quotient, it was lost when we considered common factors, so we have to keep that restriction. Therefore the final answer is this. Okay, wait up. So there is no need. However, there is just one more thing we always have to check: the quotient itself. So this is the quotient, right? X plus 2 and x plus 4. Given that the denominator is x plus 4, okay, makes it obvious that x cannot be equal to minus 4, since x equal to minus 4 would make the denominator of the quotient equal to 0. Yes, exactly. Okay, that's how it's supposed to be. Okay, so there is no need to list that value as a restriction on the quotient value, because we can see it just by looking at the quotient. So there is no need to list that value as a restriction on the quotient's value. Okay, it makes sense. So we don't need to add this minus 4 into the list, because like it will be just obvious maybe to see, I don't know. So there is no need to list that value as a restriction on the quotient's value, because we can see it just by looking at the quotient. The x equal to 1 restriction cannot be identified from the quotient. It was lost when we considered common factors. Okay, yes, because like we can identify simply what is in the quotient, but like some operation, some like factors that we considered out before, we wouldn't know what can make x equal to 0 too, because like we already considered them out. That's how it is. Okay, therefore the final answer is x plus 2 and x plus 4. So the restriction values are x cannot be equal to 1. It is easy to spot on the minus 4 because like we have it in the quotient. Okay, let's move on. Okay, let's do a couple of more examples where we follow this same process to find the quotient. So instead of doing this problem, this examples, I'm gonna get my hands on dirty. So I'm gonna do some problems. Basically, I'm gonna do problems. I'm going to do some problems. And I will see if I nail them on the head. And I will see them if I nail them on the head. Okay, right up. So should I take notes first, or should I just like do the problems? How many minutes left? Okay, 15 minutes. Can I do a couple of problems? Nah. Okay, I'm about to take notes, and then I'm gonna do the problems like in the next session. This is what I'm going to do now. Okay, let me pull out my notes. Okay. Okay. What I'm going to do is to go back. Part of rational fractions. So I think I have a question. It is just like a logical question. Okay. This is a logical question. So what it is, you know, in this second, basically the divisor, if it is numerator becomes 0 and 0 divided by something is always 0. Okay, if it is 0, this can is equal to be 0, and then I got it. That means it's just like the domain is already 0 at that point and it's undefined, which is like just error. Okay, so now what about if the numerator of the first, or maybe the first fraction, or maybe the dividend also becomes 0? What about that? It's just like, isn't it 0 divided by something and then it will be 0? So the dividend of this fraction will be also 0, and x plus 4, x minus 1. This is what it will be. Yeah, okay. So here is 0. I mean 0. Won't this one equal to 0? Okay. I'm about to go and ask ChatGPT. Yeah, the AI basically. Okay, so all I said is, the quotient will always be the range, I guess, right? Because like we got the domain and we are looking for the range. So what I ask is the quotient the y aka the range? So is it okay the range to be 0? This is how it is in a logical way. This Basically, what I'm asking is just like, is the is it fine the range to be 0? That's what I'm asking. I also run out of time, I guess. I don't have that much of time to keep talking about this, although it is interesting to be honest. So I'm gonna take 10 minutes of break and I'll be back. I'm gonna get a bottle of horror. A bottle of horror first. I'm gonna eat something maybe. Maybe I can even make a coffee for myself. Can I make that? I don't know. So yeah, I'll see. Dun 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 dun. I like this music to be honest. I don't even know if it is copyrighted. Oh my gosh, I'm in trouble if this is copyrighted. Then that means like every video that I have recorded will be taken down. It's just like, yeah. This is my second session, and it will be my last session too. So yeah, I took all of the like necessary notes that I needed to take. So all I want to do now is to do some problems. That's it. To do some problems. I'm kind of so energetic today. Wow. I was kind of feeling sleepy when I like sit down at this at my desk. Basically, I was feeling sleepy and I was so bored, and that's why I was reading stuff out loud. Cause like if I wouldn't read it, I would fall asleep, man, dude. What the heck? So yeah, and I couldn't make a coffee for myself. Too. I was just like boiling the water and doing all of that stuff, just taking me some time. So yeah, let's stop yapping and let's start studying. Also, my channel is putting some views. I didn't know that. Like, it Kadar studied. My channel is literally putting some views. Look, 10 views, 5 views, 16 views, 9 views, 3 views. Dude, this just like one view, one view, one view. It's just me. But like this one who performed 10 views, is there like 10 people watching me? Or are these 10 people just like bots? Yeah. And I don't feel but by the way. This is not view button. Can somebody view but like YouTube views? Can YouTube view is botted? Yes, YouTube views can be botted. Yeah, so you can do it. I don't know Twitch, so Twitch is just like fucked up place that you can bot the entire like viewership. So yeah, let's go and start studying. Correct this one.
4 minus 2 is 2. Now let's focus on dividing rational expressions. So let's say if we have x squared minus 9 divided by 4x plus 20 over x squared plus 8x plus 15. So how can we divide these expressions?
Yeah, I'm gonna try it. What up? So I guess square minus 9 and 4x plus 2 x square plus 8x plus 15. This is what I have. By the way, yeah, then x minus 3 and x plus 3. I'm also gonna flip the sign. X square plus 8x plus 15 and 4x plus 20. Yeah, bye. So what I find is x minus 3 on the numerator and x. Okay, I got like x minus 3 and x plus 3 bracket square. So that means I got x plus 3 and x plus 3 and x minus 3 on the numerator, and also only 4 in the denominator. That's what I have.
Well, first, let's turn this into a fraction. Let's put x squared minus 9 over 1. Now, perhaps you heard of the expression keep, change, flip. Well, here's how you use it. Keep the first fraction the same. So let's rewrite it. And then change division to multiplication. And then flip the second fraction. And now all we need to do is factor and cancel. X squared minus 9, we can factor as x plus 3 times x minus 3. X squared plus 8x plus 15. Two numbers that multiply to 15 but add to 8
3 and 5.
are 3 and 5. So it's going to
They're
be
both gonna be positive.
x plus 3 times x plus 5.
Yes, I got that. And on the bottom,
4x plus
it is
20.
just like
We can take out the GCF, which is 4.
4 and then
And
x
that's
plus
gonna
5.
leave behind x plus 5.
I'm gonna cancel x plus 5 and
Now
x
we want
plus
to
5.
determine
That's
the
what you
excluded
need.
values. The excluded
Okay, the excluded values just that's that. I missed that part. I didn't do an exclusive values. I didn't do none of that. So yeah, it's fine. I literally forgot that. It is going to be basically minus 5. And also minus 3, why not? On the top, this can also be negative 3, right? So it will make this it will make this 0 and 0 times this, which is like make everything 0.
value is negative 5.
What about
see that
negative 3?
But also, this is in the bottom of a fraction. So, which is x plus 3 and x plus 5. So negative 3 and
Yeah.
negative 5, which correlates to this part, while it's in the bottom of a fraction, those are excluded values too. Now let's cancel. The only thing that we can cancel is x plus 5. And these two, we can write it as x plus 3 squared times the other one, x minus 3, divided by 4. So that's the final answer for this problem. 4.
Am I right, chat? Am I right?
So that's the final answer
Yeah, I'm right. Got the right answer. So yeah.
for this problem.
Oh,
Let's try this one. 4x cubed plus 32 divided by
maybe I can have a skeleton row in here. I don't know. Like maybe I will need a skeleton row. Like this. I like it to be. I'm a dark mode guy. I'm a dark mode kid, dude.
minus 24 divided by 3x squared minus 6x. Plus 12 over x squared minus 7x plus 10. So
like the first, like the numerator of the dividend, or maybe like the first fraction, we're gonna use it for the what was the difference of cube. I think we're gonna use it for, we're gonna use that method for the first numerator of the first fraction, or maybe the dividend. You could not fool me. I remember that method. So yeah, maybe let me try it, and I'm gonna take a shot. And I heard you miss 100% of the shots is that you don't take. Minus 24. Now, what we wanna do is, I'm gonna flip the sign and also use the reciprocal of the second fraction at the same time to save some time. And that's how it's supposed to be, for I think. there is something that I'm asking, to be honest. Okay, and it is, you know, in this part we need to use the difference of cubes. Cubes, basically difference of cubes, which has a formula, and it was just like a cubic plus b cubic, you know, and then a square minus ab plus b square b square. It was that. Oh. The Python will be kind of long, so like, and it will be two separate parts basically. Okay, so the first one will be just like the cubic of a and the cubic of b. I think that's what it will be, and the second part will be, it's like a bit longer. And to be honest, I can make some shots while trying, but I don't know exactly what am I going to do with it. I kind of know how to factor all the parts, but like I don't know which part that he will use for the first numerator.
How can we simplify this complex fraction?
Can I just see it?
Which plus b squared. We can
Yes.
use this formula a, and so
It will be kind of long. So will he write the whole thing, or will he just write this part? That's what I'm asking.
So this is going to be 4 times x plus 2 times x squared.
Write the
minus
whole thing.
2x plus 4. And x squared minus 4. That.
Okay, the whole thing. Yeah, will this be like x minus 2 and x plus 2?
It's x plus 2 times x minus 2.
Okay, so he will write the whole thing. Okay. Now let me do it. So a cubic.
Now it turns out that
So the final answer I got 4x minus 20 in the numerator and also 18 in the denominator. That's what I have. So let me see also the restriction values, like the values that I have to explicitly mention to exclude from x, just like values that I can say x cannot be equal to that and that. So like it is making the domain undefined or zero. So x cannot be equal to minus 2. This is the stuff, let me write. X cannot be equal to minus not 2, positive 2, negative 5. I see these two now. Two. What else? Yeah, let me see. So x cannot be equal to 2 minus 2 and 5. That's what I have.
we cannot factor x squared and minus 2x plus 4. So we just have to leave it the way it is. Now let's cancel. We can cancel those two. We can get rid of x plus 2 the way it is. Now we cannot factor x squared and minus 2x plus 4. So we just have to leave it the way it is. Now let's cancel. We can cancel those two. We can get rid of x plus 2 and also x minus 2. 4 over 6 can be reduced to 2 over 3. And we have this other 3 as well. So the final answer is 2 times x minus 5 divided by 9. That's it.
So I did only one mistake, which is like I didn't reduce these 4 and 6 into 2 and 3. I didn't do that, but I think I did good the rest. Even what I can do is just like I can like reduce what I have now, so I can say gonna take out like 4, I believe. Then I will be having 5, yes, for sure. And what about on the bottom? Wait, so let me just do 2, then 2. So what I can do is Mm. I'm asking now is this, can I reduce? Okay, this is a little bit big. I'm asking is this, can I reduce 4x minus 20 so divided by 18? Okay, so I think the only greatest common factor that both the numerator and the denominator can share is equal to 2. So you cannot factor out 4 of 18. You cannot do that. The only GCF will be 2. So what if I do 2? So if I do 2, I will have 2x in here and also minus 10. So I will have 10 in here divided by, if I factor out 2, I will have 9. This is how it is. So at the end, these two will cancel. So I will be left out with 2x minus 10 and divided by 9, which is incorrect, which is not equal to this. So yeah, I think this problem cannot be fixed in this way, so I have to go back all the way to the previous step, right?
So let's say if we have...
What about the excluded values, basically?
So
He didn't mention it, right?
And we have this other 3 as well.
So the excluded values will be plus, like, positive 5 and positive 2, and also negative 2. Negative 2 right here. Right, that's all I know.
So the final answer is 2 times x minus 5 divided by 9. That's it. So let's say if we have the polynomial 8x cubed minus 4x squared plus 12x. A polynomial is simply an expression with many terms. And we're going to divide it by a monomial, or one term. Whenever you want to divide it by a monomial, you can separate this fraction into 3 separate fractions. So basically, you want to divide every term on top by 4x. 8x cubed divided by 4x, 8 divided by 2 8 divided by 4 is 2. X cubed divided by x is going to be x squared. You got to subtract the exponents. 3 minus 1 is 2. So this is going to be 2x squared. Negative 4x squared divided by 4x is
This will be all x.
simply negative x. And 12x divided by
Will be 3.
4 is 3. So that's the answer. 2x squared minus x.
Oh,
plus 3.
interesting.
Let's try one more example. 36x to the 5th minus 63x to the 4th plus 72x cubed divided by 9x squared. Feel free to try this example.
Feel free to try out this problem.
9x squared. Feel free to try this example.
Try this try this example. I think, do I have the time to do it? I don't think so. It's already got only 5 minutes left. And yeah, so I think I'm gonna wrap it up right here. Maybe I'm about to go here and do this.
In this video, we're talking about multiplication.
Oh my gosh, these are tedious, bro. Do they need a lot of reasoning? I don't know. Yes, they do, for sure. So yeah, this problem, and with the time that I got, it's just so simple, dude. Yeah, I'm gonna wrap it up right here. It was day 9 of studying math in every day.